Welcome to this tutorial presented by oraclecoach.com. This is Claire Rajan, and in this tutorial I'll be introducing you to some very basic Oracle database concepts. The objectives of this tutorial are to understand data and the database, to understand what a relational database management system is, to look at how data is stored in a database using tables, to understand some basic concepts associated with a table such as the primary key, foreign key, null values, to understand what is meant by the users of a database and the definition of the word schema. I'll also be introducing structured query language or SQL, and we look at some tools that are used to access the Oracle database. We'll first begin by understanding data. Data is something that I'm sure all of you are familiar with in some form or the other. By definition, we can state that data is a fact that needs to be stored for future reference. Companies store details about their employees, including the name of the employee, the department that the employee belongs to, the salary that the employee earns, the date the employee was hired, and other details relevant to an employee. Now, in fact, all of us maintain some form of an address book that contains the names and the addresses of our contacts and friends. Now, whenever we deal with data, it always pertains to some object or of interest to us. Here we have an object that has been identified. The object is a person. Objects must most often mimic something that exists in the real world. For instance, objects could be books, employees, customers, suppliers, events, shows, etc. An object is described by its characteristics. In the case of a person object, a person would have a name, a date of birth, and may or may not hold a job. Now, in database terminology, an object of interest is called an entity, and the characteristics that describe the object are called as attributes. Now let's consider this example of a university. We know that a university is a place of learning, and the types of objects relevant to a university would include students, courses, and faculty. There are three entities that have been described on this slide: the student entity, the course entity, and the faculty entity. We also have a list of a few attributes for each entity. The student would have a student ID, a name, and the course that the student is enrolled in. The course would have an ID, a name, and the duration for which or the length of time for which the course would run. The faculty would have an ID, a faculty name, and would be associated with a course which the faculty teaches. Now that you have an understanding of what is data, let's look at what a database is. By definition, we can state that a database is a centralized repository of related data. Now, going back to the previous slide, the data that was relevant to the university was students, courses, and faculty. Now, I'm going to move ahead just a slide to show you what a database would be when in relationship with a university. Here we have all the data that was important for the university stored in a centralized manner. Okay, all contained within one unit or one logical object, which is over here in the form of a cylinder. And what we say over here is that the database would be the centralized repository of all of this data. So a database consists of data pertaining to one or more objects of interest, and these objects may be related to each other. Taking the example of the university, a student enrolls for a course, so the student object or the student entity is related to the course object or course entity. Now the relationships are maintained and managed within the database itself. We now try to look at what is meant by a database management system. Now, a database management system is a software that allows a user to interact with a database. The database management system, if you look at the diagram, is between the user and the database. The database management system provides interfaces that allow the user to interact with the data. The database management system takes care of storing, defining, and managing all the data that is within the database. And there are many types of database management systems available, and one of the most popular ones is the Relational Database Management System, that's abbreviated as an RDBMS. Now the previous diagram has now been modified a bit, where between the user and the database we have the Relational Database Management System, or the RDBMS. Also observe the way in which the data itself has changed. Earlier we had each entity described in the form of a circle. Here we have each entity being displayed in the form of a table or a two-dimensional structure. Now, when you're working with a relational database management system, all the data that is stored in the database is represented in the form of two-dimensional structures known as tables. Here we look at some of the basic concepts associated with a relational database management system. Firstly, a relational database management system is one that represents all the data in the database as tables. Now, tables are your basic storage structures. They are two-dimensional, consisting of rows and columns. And in addition to tables, a database can also store other types of objects. Here we have a list of the other types of objects that can be created in a database in addition to a table. You can have views, sequences, synonyms, indexes, constraints, and triggers. Now, these objects that are listed are optional and may be created for specific purposes. For example, a view may be created to restrict the data in a table. An index may be created to access data in a table faster. A constraint can be created for greater accuracy and data integrity. We now have a look at what is meant by a table. A table is the basic structure of data storage. Now on this slide we have a table that has the name employees. Note that every table must have a name. Now the table is two-dimensional, consisting of rows and columns. What you see vertically is a column. What is horizontal is a row. This table has 4 columns. Each column has a name. The names of the columns are employee ID, first name, job ID, and salary. The table has 3 rows. The rows are the actual instances of the employee object. The details of each employee in the company will form a row in this table. We'll now look at some important concepts associated with tables. This specific slide shows you 2 concepts. One is the primary key and the null value. To understand what is meant by primary key, take a look at the data in the employees table. There are 3 rows for the 3 employees in the company. Have a look at the second row where the employee's ID is 101. The name of that employee was Nina. The employee's job ID was AddVP and earned a monthly salary of 17,000. Now also observe that every employee has a unique employee ID. Now this column would probably be the best way to identify an employee uniquely. In a table, the column or the columns that can be used to uniquely identify a row of the table is called the primary key column. In this table, the employee ID column is the primary key column. Now, the next concept being described by this slide is the null value. A null value is defined as an unavailable or an unknown value. Now, in this table, the job ID for employee 100 is a null value. When I say null, it means it's unavailable or unknown, and maybe at this time the job of the employee Stephen is yet to be determined. Another important concept that is associated with tables is that of the foreign key. A foreign key by definition is a column or columns whose values must be existing values in a primary key column of either the same table or another table. Now on this slide we have two tables, the employees table and the jobs table. The employees table contains the details of employees of the company. The jobs table describes the different jobs in the company. The jobs table has two rows. The first row describes the job where the ID is Ad Press and the title is President. The second row describes the job where the ID is Ad VP and the title is Administration Vice President. Now first of all, let's take a look at what the primary key in the two tables would be. The primary key for the employees table would be employee ID. The primary key in the jobs table would be job ID. Now there is a relationship between these two tables, and the relationship is defined by the job ID column in the employees table. Notice that some of the employees also have the same job ID. Now what is important to observe is that the values in the job ID column of the employees table are all existing values in the job ID column of the jobs table. There is a relationship being created by the data in these two columns. Now if we say that an employee must hold a known job, then the values taken by the job ID column of the employees table must be found at all times in the job ID column of the jobs table. Here the foreign key column is the job ID column in the employees table. A foreign key can exist within a table itself. Have a look at this slide where we have a table called the employees table where there are four columns. The fourth column is a new column which is the manager ID column. Observe the employee ID values are 100, 101 and 102. The manager ID values are 100 and 101. Now what we are trying to say over here is that a manager is always another employee of the company. If you look at the second row where the employee ID was 101, the name of the employee was Nina, whose job was Ad VP, and her manager's number was 100, or the employee whose name was Stephen. Now the values taken by the manager ID column must be existing values in the employee ID column of this table, because a manager is always an employee. Here the manager ID column is referencing the employee ID values and is therefore the foreign key column within the table.